This is an update on ADS version 1.3.7. This release has a updated trim tool, so you can define plate parts with a closed curve and use this plate thickness attribute. Plates are rendered in wireframe so that you can see the interactions with other components. These can be cut with G-code, can be exported to G-code and then cut with the plasma table. The trim tool will let you select the tool as it intersects with other objects like this tube. It will notch the profile. You can see the plate is at an angle so that I can see how the cut will have to conform to the tube. Here's a multi-notch example. You can see there's an artifact on the end here, so we will clean that up eventually. You can see that because this tube is at an angle that the profile has to cut away so that the edge will make contact. Another feature that we've introduced is the flange tool. So if I select a bolt object and a tube, now I purposefully put this bolt off axis from the tube just as a demonstration. So if I select both of the objects, I can select the plate thickness and it will generate plates on the head and nut location that intersect with the tube. This is good for building fixturing on your tube frame design. You can model the tube frame so that it is to your structure with fitment, and then you can add the pivot points or mount fixtures with the bolts and then create the plates to connect them. One other new tool that we have is the flange tool. So we can construct flanges that join two tubes. So in this case, we've got two tubes on the same plane that butt up against each other. They don't have to be perfectly touching. They can be separated or overlapping. If I select both of these tubes, I can select the Create Flange tool. And it gives me some options. The plate thickness as both, unless you specify a second. You can create different shapes, rectangle, square, circle, and diamond. And bolt count, the number of bolt holes for fixing the two together, the diameter of the bolts, and the weld clearance is the calculated estimate between the circumference of the bolt and the surface of the tube for welding so that the bolt hardware can fit together. Based on your preferences, some of the options will be overridden. So if I select a diamond shape, it's always going to generate a flange with two bolts, as an example. In this case, it's created flanges that connect each other with bolt holes and tabs and slots. So I'm going to pull this apart for demonstration. If I select the tube, pull it away, then we've got two flanges. I'm just going to pull them away so that we can look at it. The shape, this is the first version, so we'll make it look better eventually, but we've got two holes for the bolts and then four slots for alignment. And the tubes have notches for the end profile. This is the surface, and then it has four tabs for alignment with the flanges. Now, one thing you may notice is if I look at it from the side, the orientation of the flanges and the alignment pins is always going to be vertical. This will allow us to generate consistent designs. So let's try some of the different shapes. Let's try the rectangle. You can see the purpose of the rectangle is to get four bolts for extra gripping strength and to keep the height compact. It's best practice if the tubes actually do butt up against each other. Otherwise, it will do its best. What? Right. And on purpose for this example, these tubes aren't aligned on the flat plane. They're purposefully at an angle. Circle. So we've got rectangle, square, circle, and diamond for now. One of the other tools that we have is the trim tool, applies to mesh surfaces as well. So one of the things that we're doing is modeling components using multiple meshes that intersect. So we can create the form on one side that we want to replicate with a part. To manufacture that though, because we want a mold negative, we want to actually generate the G code that will process make molds based on the backside surface. So the trim tool comes in where we can use the shape that we've generated, but we want to cut off this excess lip so that the G code can be generated based on the back surface. When we get our mold, then we lay it in the fabric. We'll get a part that represents this top surface. Now we have two different types of mesh objects, spline and triangle mesh. Spline is more restricted in its shape type. It is restricted to columns and rows, so the same number of rows and columns as columns and rows. So when we trim, we can only trim the outer edges. So this is a spline mesh. It has the same number of rows and as on each side. Same number of rows in columns and rows. So we can't trim on the inside of we can only trim the outer edge of a spline mesh because we can't support the geometry of making non-uniform shapes. So in this case, I'm going to take a spline mesh and trim. One object updated. And you can see it's pulled the edge points to meet the intersection of the intersecting object. Now, triangle mesh has more flexibility in the shape that it wants, but because we don't know what behavior is desired for an intersection, it will, instead of trimming, it's going to add points and then let you choose what you want to do. In this case, I'm going to click trim and then inspect. What it's done is added these new points at the intersecting location. So now we can trim the side that we want. This way we can construct mold forms and shapes using multiple different types of meshes and have them cross another to get a clean edge and then just trim when we're done and generate the G code. So one of the other things that's relevant to plate parts that are based off of these curves that are closed with a thickness value is in modeling in 3D space, we can have it interact with all of the scene elements that we want. But in order to cut it, we need to generate G code that will instruct a plasma table to cut the parts. So what we want to do is select the object, under CAM, select layout, and now it's going to put it in the layout mode. You can see it's a different color and it's indicated with an asterisk under the part number. So I can move it and align it with other parts and use this flatten tool. And this will align the part on a flat surface so that I can pack it along with other parts and then generate G code with this on a flat table. So the plasma table is always going to cut parts laid flat. So this is in the layout mode. So when we're done, I can go back to modeling and it will be rendered in the 3D space. Now when I generate G code, plate, G code, and then I can view the properties, generate the G code, and then click on the G code icon, G code for the parts in the file. And I can send this to the machine and have the parts cut. So that is it for this release.